My name is Mardhav. I'm an 8th grader who goes to Sauk Middle School, and this is my project, Phenomenal Filtering. My research question for this project is, how does a grade of sand impact the pH level of water in a natural earth filter? I conducted this experiment because it can be used in the real world and because I'm interested in natural filtering. I did learn a little bit about natural filtering in years prior, but it was very surface level. I also wanted to make something and do something that other people could easily understand and could easily replicate. How I did my experiment. First, I needed to gather my materials. My materials list goes as follows: water, vinegar, bricks, wood, a drill, pencils, styrofoam, scissors, pebbles, charcoal, sand of 5 different grades, 2-liter bottles, and cotton. The specific measurements for each of these items are on screen now. Next, I had to make the filters. To do this, I took equal measurements of sand, charcoal, and cotton, and pebbles. And what I mean by equal measurements is the amount of each of these items was not the same, but it was the same amount of charcoal in all 5 filters, the same amount of cotton in all 5 filters, the same amount of pebbles in all 5 filters, the same amount of sand in all 5 filters. But the amount of sand was not the same to the amount of charcoal, which is not the same amount to the amount of pebbles, and that was not the same amount of pebbles to the amount of cotton. After I got my equal measurements of everything, I had to layer it in the bottle. The bottom layer was made up of cotton. The next layer was made up of charcoal, which was a layer. Then it was sand, the second highest layer, and at the very top were the pebbles. I drilled a hole in a piece of wood and styrofoam so they'd be the same size, and so that way they would line up. After, I stacked 2 bricks underneath the wood on each side, which would create a pair of legs. I put the styrofoam on top of the wood and the filters with the contents inside of them. Here's a diagram of what I'm talking about. The wood and styrofoam each had 5 holes in them, so I could put all 5 filters in at the same time. And I put cups underneath for the collection process. I also had to rig the water, which I would do by using vinegar. I made a ratio of vinegar to water 20 to 1. 1 to 20. This would set the pH to 4. After double checking the pH to make sure it was 4, I would pour the water through the filter. After letting the water run for 20 seconds after it started dripping, which was at the end of the filtration process, I would measure the pH of the water, the volume of the water, and the time it took for the water to filter, although I could only do this for 2 trials. I would record my data into Google Sheets, repeating the process for all 3 trials. I did all my work by myself, besides my mom helping me take some pictures, and my dad helping me drill holes in the wood and styrofoam. My data. My data is right here in this data table. As you can see, the very fine sand did the best job of filtering the water. As aforementioned, the original pH of the water was 4, and the very fine filter brought the pH all the way back to 7. This means that the filter did its job when it brought the water back all the way to neutral. However, the coarser the sand got, the more acidic the end product was. As the sand particles got bigger and bigger, the effect on pH was less and less. It got to the point where at coarse and very coarse sand levels, the water was not even being filtered, but it was more like it was just running through the filter. These are 2 graphs based on the data table. The first basically shows the full data of all 3 trials and for all 5 filters, and the second one really shows the averages. And as you can clearly see, the effect from very fine to very coarse filters, and how very coarse filters didn't do anything compared to the very fine filters, which really made an impact. Here are 2 other graphs of some different data, which is the amount of liquid kept from after I poured the water through. I started each trial using 437 milliliters, or about 2 cups, of water. I think that the change in volume did occur because the water spent more time in contact with the finer sand, which made more of it get absorbed. Another bit of reasoning I have for this case is that in the 2 trials where I kept time of the water for how long it took to filter, I found that the filter with the very fine sand would end up taking 1 minute more than the filter of the water through compared with the coarse filter. So as you can see, the amount of water saved goes up the coarser the sand ends up getting. And as explained, I think this happens just because it spends more time in contact with it, with the sand. So more gets absorbed into the sand. So why my experiment matters. My experiment can be used in a variety of ways. It can be used for filtering water on a big scale, as it's inexpensive and it is extremely effective. It can also be used for survival situations, or when you are in desperate need of clean water. The filter is extremely easy to make in the wild, and the experiment shows that the finer the sand, the better the results. Finally, it can be used for countries without clean water and without funding. Countries like Ethiopia, Uganda, and Papua New Guinea are perfect examples of these kinds of countries. The filter would be effective, quick, and most importantly, it'd be affordable for the families of these countries. If I had to do this experiment again, I would definitely change the amount of any and every material that I use the filter with. I would change the amount of cotton, charcoal, sand, and even the amount of pebbles to see how that impacts my results. I'd also change the size of the charcoal to see if smaller charcoal, or to see if finer charcoal, or more coarse charcoal makes a difference. Although I hypothesize that I have similar results to the experiment I conducted today. Once I figure out the best possible filter, I could then use proportions to figure out the cost. I can even attempt to find the lowest cost filter possible. I could also try to find the best size, or to see even if size makes a difference, whether a small filter or a big filter would change the results. Overall, I think I have many options for exploring this topic further. Thank you for watching my video, and thank you for judging my project. Have a great day.